Here comes Santa Claus, here comes Santa Claus. What the? It's not Christmas. No, but sometimes I use Steve Ramsar as my substitute. And he's awesome, so I just had to name drop him in this video. Yeah, turn in your homework assignment early for extra credit. Get a stamp on your paper. So we're doing 9.3 right now. 9.3, here we go. Okay, so let's see here. So good, we're doing some review with factoring. Make sure you remember how to factor all year long. Don't forget to pull out the GCF first. What they have in common, pull out the GCF. Ooh, what you doing? Pause me, remember, pause me. Try number one on your own. Then see how you did. Pause me, pause me. Pause me, try each one on your own. And then push play and see how you did. So we got 3x squared plus 2x minus 8. Can we factor that some more? 3x and x. Let's see, we get a 2. No. 2 times 3 is 6. 2 times 3 is 6, and 2 times 4 is 8. That's looking good. Side middle term goes with the bigger number, which is 2 times 3 is 6. That's a bigger number. And 6 minus 4 is 2x. We did it! Don't forget the 2. Don't forget the 2. Don't forget the 2. So try number 2 on your own now. Draw a line to the middle. Try number 2 on your own. Special factoring. You got this. Try special factoring. Try special factoring. Maybe pull out a 4 first, then try special factoring. Would that be better? I think that'd be better. Pull out the GCF. Yeah. So if you pull out the 4 first, then you're left with x squared minus 4. Way-o. Way-o. And that factors more. So factor in more. Pause me. Try it on your own first. Pause me. Pause me. Let's see here. Radioactive. Radioactive. Remember this when we did this? All systems go. But them up in my bones and then my systems go. Welcome to a new age. To a new age. Welcome to a new age. To a new age. Who sings that? Do you know? Yeah. Imagine Dragons. Let's see here. So we have an equation. Find the half-life of this substance. So they don't really give us the initial. They don't really give us that. They want the target to be a half, though, okay? So we can just call this just 1, and then we have a half. Or you can choose 40, and half of it's 20. Or choose 10, half of it's 5. Up to you. As long as you get half when you divide it over. So you get 1/2 is equal to, maybe 1, I guess, yep, times e to the negative 0.0856t. Remember doing this with logarithms? Cool, so we divide that 1 to the other side, which really is silly because it goes away. And 1/2 divided by 1 is still 1/2. But now we can leave a blank space, baby. We're all right, your name. Nice to meet you. Where you been? How do we undo E? Let me tell you. What? That's not how it goes. So how do we undo E? What undoes E to the other side? ln. Undoes E, ln. Undoes E to the other side. So then we're just left with the negative 0.0856t. And then we're just going to divide to the other side. Negative 0.856 to the other side. Remember how to do this, right? Whoa, lunchtime. Lunchtime, lunchtime's over, lunchtime. No, that's lunchtime starting, actually. That's lunchtime starting. Let me unlock the door so I can tell them if they start popping in. Here we go. It's just regular, though, schedule. Hopefully they know that by now. Okay, beautiful. So that's going to give us T. It's going to give us what T equals. This is what T equals. So you plug it into your calculator now. Here we go. So we're going to go what? We're going to go parenthesis ln of 1/2. Cool. Divided by negative 0.0856 is what we're dividing it by. And then we get T. So we get 8.09. 8.09. t equals 8.09. It says round to the nearest day. So the nearest day would probably be 8 days is what we're looking at there. Cool. Okay, rewrite each angle. Rewrite each angle in radian measure. Rewrite each angle in radian measure. So that's saying change degrees. That's saying change degrees to radians. Okay, so do not use your calculator. Okay, so all you do is our formula that we taught you. All we do is our formula, do you remember? So we times by pi and divide by, what's the equivalent of pi in degrees? 180. It's just like converting inches to feet, right? Inches is smaller, feet's bigger. Degrees is smaller, radians is bigger. Inches and feet. So we're going to go ahead and times by pi, but then we have to divide by the equivalent of pi. What's the equivalent? What's the equivalent of pi in degrees? And that's 180. So we're going to go ahead and divide by 180. And then 120 divided by 180. Well, you can divide by 10, divide by 10. That gives us 12 over 18. And then divide by 6, divide by 6. So that gives us 2 pi over 3. 2 pi over 3, way-o. What about 150? You try that one now. You try that one. Yeah, you try that one. What do you think? Divide by 10, divide by 10. So reduce it now. You got to reduce it. So is that 15 pi over 18? What's 15 and 18 divisible by? You got this. What's it divisible by? 15 and 18? Divisible by 3. So we get 5 pi over 6. Lunchtime. Is that okay? Lunchtime? You try number 8 now. You try number 8. Okay, rewrite each angle in degree. So rewrite each radian to degrees is what that's actually asking for. So now we're going to go back the other way. We're going to go back the other way now. Let's go back the other way. So to go back the other way, instead of timesing by pi divided by 180, we're going to get rid of our pi's. We're going to eat our pi. We'll just be left with degrees. How do we eat our pi? Well, we divide by pi. We times by pi, put it in the bottom so they cancel. Well, what's the equivalent of pi? 180 is the equivalent of pi, radians, right? So now we're just going to go ahead and do 3 times 180 divided by 2. And really, we could take 180 and divide it by 2 first. So divide by 2, divide by 2. So we get 3 times 180 divided by 2. What's 180 divided by 2? 90? And so that's going to be 270 degrees. Way-o. And that's true. 3 pi over 2 is 270 degrees. So you try number 10. You try number 11. Remember, you're just timesing by 180 and dividing by pi. So whatever 4 times 180 is, you're going to try. Is that 2 is 360. So would that be 720? Sounds like 720. Way-o. Nice. Use your calculator to convert each angle in degrees to radians. Right now, to the nearest 3 decimals. Really? 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 Okay. So turn it into radians, huh? So we're going to times by pi, divide by 180. And then we'll just plug in our calculator, I guess. 3 decimal places. Interesting. Didn't know they're having to do this year. I like it. So 83.7. Let's see. We're going to go times. Whoops. We're going to go times pi. Enter. Divide by 180. So we get to lunch. It's lunchtime. Is it your lunchtime? Get your lunch. Is your what the? Why can't it? There it is. There it is. Lunchtime, get to lunch. Oh, or I mean your next period maybe, because that's the bell for the next period. Okay, so we get 1.4608. 1.4608, which is going to be 3 decimal places. So that's going to be 1.461. Looks pretty accurate to me. 3 decimal places. Okay, so you tried 12. You tried 12. You got this. Times by pi, divide by 180. Use your calculator to convert each angle in radians to degrees, round to 3 decimal places. So they want you to turn 2. So what is 2? Use the calculator to convert each angle given in radians to degrees. How do we turn to degrees? Well, we times it by 180, and we divide by pi. That's going to be weird and interesting, but we'll do it. Because radians to degrees, you times by pi, divide by 180. So that's going to be 2 times 180, which is 360. And so 360 divided by pi, interesting. 360 divided by pi is 114.59. 3 decimal places, so 114.59, 114.5915. So that's going to round to 2, round it up to 2. So 114.592, nice. All right, there we go. So that's degrees is what that is. That's degrees, and this is radians. This is radians, and this is to degrees. Using our calculator. Interesting. Using our calculator. Good job. Okay, next page. Determine two coterminal angles, one positive and negative. So do you remember what we added coterminal angle? We added 360, we minus 360. Well, what is the, right, we added, so we went ahead, let's say we were here at 30 degrees, do you remember? And so we went all the way around the full circle. So we added 360 degrees, and we got like 390, for example, as a positive coterminal angle. Well, now we're going to add 2 pi, because 2 pi is the equivalent of 360 degrees. So we're going to add 2 pi now, and we're going to subtract 2 pi to get the positive negative coterminal angle. So we're going to go ahead and add 2 pi. You're going to have to convert that into fourths, though. That's the tricky part. Convert it into fourths. So we're going to go ahead and turn it into fourths. So we're going to go ahead and times it by 4 over 4. And so now that's going to be 2 times 4 is 8 pi over 4. And 8 pi over 4 is the same, right? Those two are equivalent. They're equal to each other. And so 8 divided by 4 is 2. So now we're going to do 11 pi. So 11 pi plus 8 pi over 4. And so 11 and 18 is, 11 and 8 I mean, is 19 pi. So we get 19 pi over 4 as our positive, because it says one positive, one negative. So that's our positive coterminal angle. Now to get the negative, dark side of the force. You're going to minus 2 pi now, which is the same as, what did we figure out 2 pi is? So 2 pi is 8 pi over 4, so now we're going to minus it. And so they're both fourths, so we're just doing 11 minus 8 and then fourths. Combine the top over the bottom once. So 11 minus 8 is 3, so 3 pi over 4. And that's a negative coterminal angle. So you try with number 16 now. You try with number 16. Draw each angle in standard position. Find the angle of reference angle. State which quadrant the terminal side lies in. I like it. Okay, so then we're going to go to draw like that. And so 8 pi over 6 is a tricky one. 8 pi over 3, I mean, is a tricky one. So I'm used to doing it in sixths. But we can count by thirds. Can we count by thirds? Ooh, that'd be tricky, huh? Let's do sixths then. So I'm going to go ahead and times this, because this is just how I know how to do it. So we're going to times it by the top and bottom. We're going to get 16 pi over 6. And you could convert it to degrees if you really wanted to, and then find it and do it that way. I'd be fine with that. But I know that this is 1 pi over 6. This is 2 pi over 6. This is 3 pi over 6. 4 pi, 5 pi, 6 pi over 6, which is just equivalent to pi, or 180. 7 pi over 6, 8 pi over 6, 9 pi over 6. 10 pi over 6, 11 pi over 6, 12 pi over 6. You're going to overlap now. 13 pi over 6, 14 pi over 6, 15 pi over 6. There it is. 16 pi over 6. 16 pi over 6 is what that is. So we went all the way around to there. And that's going to be 16 pi over 6. So state which quadrant the terminal side of the angle is. And so this quadrant is quadrant 2. So that's our second answer, quadrant 2. Okay, now find and label the reference angle. Find and label the reference angle. Okay, so the reference angle is going this direction now to here. And so how many more radians is that, is the question. And so we're going by pi over 6. So that's 1 pi over 6, and then 2 pi over 6 is what that is. So 2 pi over 6 is our answer for the reference angle, or that reduces to pi over 3. Way-o. Pi over 3, let's check number 19. Way-o. Yep, pi over 3. Woo! Nice. Awesome. Possum. So thanks for watching. We'll do another video here in a second. Keep on going. You're doing good. You're doing good. Keep on watching. Keep trying the next one on your own. Try 18, 20, 21. Try doing it without me, and then come back, push play, see if you got them right. Thanks for watching. See you soon. Bye for now.